Now this problem is a little bit different, but I think it's very doable. Um, so again, I'm given a reaction, and I'm given a temperature, which I can promptly ignore. The equilibrium constant for this reaction, oh, so this is different. They give me Keq, and that's interesting. So that's a little different. What will be the concentration of NO2 at 1000 Kelvin present at equilibrium if I'm given these concentrations? Okay, so we're going to start out by writing our equilibrium expression, and we put our products on top. And this time the coefficient is 2, so we're going to square that over concentration of our reactants, so concentration of NO squared, because that's to the 2, times concentration of O2. Alright, now, what am I trying to find here? Well, I'm trying to find concentration of NO2. That's my question mark. Alright, so we've done problems like this all year long, and I continue to emphasize to you the importance of isolating the variable you're looking for. So I'm going to multiply both sides by the denominator to get rid of it. Over 1. Okay, so that gets rid of these two things. All right, and now I'm left with concentration of NO2 squared equals Keq times concentration of NO squared times concentration of O2. All right, now the only thing that you got to be careful of here is this concentration of NO squared, which I don't really want. I just want concentration of NO, which means I have to square root both sides. So this is really what I'm going to plug into. So concentration of NO2 equals square root of a lot of stuff. Keq is 1.315 times 10 to the minus 2 times concentration of NO, 6.200 times 10 to the minus 2 quantity squared times concentration of O2. Okay, and once again, you'll notice that I'm totally leaving out units. All right, this is going to be slightly problematic at the end of this one, but it shouldn't be too bad. So you multiply all these things together, make sure you square this, okay, and you get, and then you take the square root, and you get 6.479 times 10 to the minus 4. Now, I don't have a unit in here, but I know that concentration of the product is probably going to be the same unit as concentrations of the reactants. So I'm just going to use molar. All right, don't forget the units. You still have to put units in where they are appropriate.